Yeah, so welcome back. This is day 3. And yesterday everyone's got the Wi-Fi, right? Okay. So yesterday I did a very quick introduction to Wekinator, but we didn't really do very much with it, right? So today we're actually going to begin to build some examples for Wekinator and do some interactive machine learning. So this is going to be kind of a continuation of what we did yesterday. There will be a few differences though, which is that number one is going to be not in the browser, but actually using applications on your computer, mainly processing. So we'll have a little bit more control over it, although there will be less integration into the internet, which is, that's the trade-off. And then we'll see that may more or less be, depending on how quickly things move, that may be most of what we do today. If we have enough time, we may start on that thing that we did just at the end yesterday, the notebook that showed we didn't show anything in it, we just ran it, but in Colab, when we did online, the Google thing, we may start to make generative graphics, and that's kind of the second phase of the workshop. So there's kind of two phases. One is this interactive real-time stuff, and then the second phase is this more making generative art. And we may kind of pass the baton, so to speak, later today, or maybe just start on that tomorrow. We'll see how things go. So yeah, let's do some Wekinator. So let me just, again, I'll take you on a tour of Wekinator, and feel free to follow along. If you want to open it, you basically get this screen here, and I'm going to tell you more about what it is and what it does. So I already did that yesterday, so I'll do this briefly. So yesterday I mentioned that Wekinator is this application that looks like this, and actually, when you go to the next screen, you'll see the main screen. This is kind of the setup screen. When you are creating a new project in Wekinator, I'll just go to the main screen. This is mainly what Wekinator looks like after you've created a new project. And what happens is, what this is doing is it gives you some number of either classifiers or sliders, buttons or sliders, let's say, which you can use to control things in other applications. And I'll show you how to do that later. But the idea is that this slider, right, or all 5 of these sliders can control processing or Maximus P or whatever software you have that takes in OSC. You can kind of bind these sliders to important numbers in whatever application you're using, for example, processing. And what we can do is we can learn to control these sliders using some interesting input source, like our webcam or sound, and we'll look at a few of those examples today. And let me actually, not to be so abstract, let me just go straight into an example so you see. So I'm going to actually get out of Wekinator, and I'm going to open Wekinator again and go to this login screen, and you can go ahead and do this also. If you go to the Wekinator processing folder, there is a folder called Combined Inputs Output, right? And then you'll see inside there's a PDE, so there's a processing sketch. So you can double click that and it'll open processing. Now, if you didn't have processing before in your computer, there's one thing that you're going to have to do right now, which is to install the OSC P5 library. So and you need to do this if when you press the play button, if when you press the play button and it gives you an error on the red, it says red at the bottom, that you're missing a library, then you have to do the following. Let me actually just make this a little bigger for you guys. Is that visible? Reasonably. So do the following. If this is your first time using processing, go to the sketch. So go to Sketch, Import Library, and Add Library. and you should see a screen like this. And search for OSCP5, and you should get a search result here at the top, OSCP5. And basically just click on that, and then this button should be available to you, install. So click on install, and it will download and install the OSCP5 library. Okay, so it's pretty small, but everyone has to download it, so it might take a few seconds. And I guess I will update to 0.9. Yeah, why not? So that should go pretty quickly. Is everyone see OSCP5? Any problems there? Raise your hand if it installed successfully. Okay. Raise your hand if you're still installing. Okay, so I'll just give you a couple minutes. Once you have installed it, you should be able to run this sketch. So if you hit the play button, you should get something that looks like this, that opens your webcam.
I'm missing processing of video.
Really? Oh, that's strange. I thought that comes with processing. Okay, wait, if you're missing processing that video, search for video. Oh, that's so weird. Wait. Video. Hang on a second. That's actually confusing to me because I thought the video library comes with processing. Sorry? Really? Why did they do that?
It's still a processing maintained library, but it's not part of the default.
Okay, so you should be able to find it, I suppose, in the same way. Yeah, I just searched for it though and I couldn't find it.
It should come up if you type in video.
Yeah.
You should see GStreamer.
Right. Actually, I'm having some trouble here. Okay, I'm getting a blank screen. Does anyone else have some bugs like this? Alright, hang on a second. It worked eventually? Okay, so people are installing video? That was news to me. So yeah, you should be able to search video. Yeah, there we go. Yeah, exactly, this GStreamer based video library. So if you don't have that, then install that as well. So the one that's by the processing foundation.
You get an ugly red error, but then the sketch seems to run anyway.
Oh, that's probably not a big deal. Basically, you should be able to get this. How many people see what I see? It's camera pixelated. Okay. How many people still working? Okay. Yeah, downloading. Okay. All right. Yeah, it's a bit slow, I suppose. How many people still downloading? Oh wow. Is it really slow? Is it the network is slow right now? I feel like the network is kind of slow for me. Yeah, okay. Because I think it's like a few megabytes at most. Of course, everyone downloading at the same time is suboptimal, but alright, let's give it another minute. Maybe like while it's downloading, let me actually just at least take you through the code so you kind of see what's going on, so we can kind of just let it be, and we won't run it right now. Okay, can I get everyone's attention? Okay. Oh yeah. Repeat what? The directory. Oh, it's so the program is in Wekinator processing, combined inputs outputs. Yeah, oh right, and then classifier webcam, yeah. So let me just explain what's happening here. So this processing sketch is pixelating the webcam. It basically takes your webcam input and creates a 10 by 10 grid of pixels. And out of this, I think then it becomes grayscale. You don't see it in grayscale, but it's grayscaled in the background. And so there's 100 numbers. At any given time, there's 100 numbers. And then what we're going to do is that this sketch basically will show like one very basic use case for Wekinator, which is like creating a camera classifier. Like the kind that we did yesterday with TensorFlow.js, like in the browser. So basically we're going to create a classifier that you can train with your webcam. Now this one is a little bit different because instead of using, before we were analyzing the webcam with a convolutional network. So it was taking the feature extraction from there. Here, all it's doing is it's literally using the input pixels, these pixels, as the input to the network. So it's much simpler, and it's much simpler. So it's kind of like not as good of an image classifier, but it's very, very simple. So it lets us see the whole process end to end. So what's going to happen is that processing is going to continuously send the values, these 100 pixels, to Wekinator, and Wekinator is going to have a classifier which lets us train several image classes to recognize different kinds of camera inputs. And then Wekinator will do all of the machine learning and then send the classification data back to processing. And then processing will have that for further processing, of course. So you can kind of, I guess what we'll do is we'll look at the code. Let's run the program first, and then we'll look through the code. How many people are you still downloading? Some people. How close is it to download? It's like very close. Okay. I just want to know if it wasn't one of these things where it'll take like 4 hours or something. So it's going slowly. So okay. So in the meantime, we can set up Wekinator while processing is finishing importing. So go to Wekinator. And you'll see here at the top of the processing sketch, it says that Wekinator requires here 100 inputs, 1 output, all classifiers, with any number of classes. So let's do this. We'll go to Wekinator, and we'll say Wekinator listening for inputs and control on port 6448. So let's click Start Listening. Now, what is this port 6448? So I think a lot of you are not familiar with OSC, right? We talked about OSC briefly yesterday. So OSC is a protocol that lets applications communicate to each other over a network. And that means since it's over the network, it's a form of UDP. It's like a network packet. And network packets go through ports. So why 6448? No reason. It's just arbitrary convention. The point is that the two applications that are communicating must agree on which port they're going to communicate over. And two applications cannot both be listening to one port at the same time. So just remember that in the future, if you're running multiple OSC apps, you might get collisions which cause one of them to fail. So for now, we'll just use 6448. And then in the inputs, it says, okay, I'm listening for inputs along this with this message. And we're going to just use the default. You can change this in principle, like as long as they agree, you can always change it. But we'll just use the default. /wek/inputs. The slash doesn't mean anything. It's formatted like an address because sometimes by convention we have multiple messages that are kind of formatted like addresses. But it's just a string. It doesn't actually mean anything. So the number of inputs has to be, for this case, 100. Okay, so make sure you change that to 100. And the outputs, we're going to have one output. So you see where it says number of outputs? Change that to one output. The host, which is where are we sending it to, we're going to keep it on our own computer. So that means just leave it at localhost, port 12,000, and then change the type here to all classifiers. And let's leave it at 5, that's fine. So all classifiers with 5 classes. So make sure you have these settings. Okay. So everyone's got that? How's that video library coming? It's good? How many people are still downloading video? Everyone's got it, yeah? Okay, cool. So that means we should be able to actually do this. So anyway, when you have all of these settings, click Next. And then you'll see the processing screen come up. And here's our interface. So what we have now is we have just one of these. We have output 1. And output 1 has a drop-down menu that has which class. There are 5 classes. We said there's this one classification with 5 classes. And this number right here is how many examples we have recorded for this value. So this is very similar to the interface we were looking at yesterday in the browser. Each of the values we had, the classifiers or the sliders, would have some number of examples recorded for it. And everything else we can just leave that be. So basically what's going to happen is, as soon as we hit start recording, when we hit start recording, Wekinator begins to listen for examples from processing. Processing will then send those examples to Wekinator, and what it's sending is the values of those 100 pixels. So that becomes our input. And then it's associating them with whatever class is selected. So I'm not going to hit start recording yet. I want to run this sketch first. So when you run the sketch, for how many people is this working? So you should get, after a moment, pixels. Anybody having any problems? I'm just curious if everyone's getting the same problem. Can you state?
Getting a null pointer exception.
Null pointer exception. Null pointer exception. That's interesting. I'll have to look later. Do you have exactly? Anyone else getting null pointer exception? Okay, so I'll take a look later. It's probably, maybe you're missing the files and data. Is there a file in here? Roboto regular.
Yeah.
Okay, we'll see. Try firewall. Oh.
Ports are closed that OSC wants to use.
But I don't think it'll give you a null pointer for that. I don't think.
Unless they're handling the exception correctly in processing.
Oh, sure. Okay, well, yeah, I'll take a look at that. I'm not sure what could be causing that, but for most people, this should be working, right? Okay, so basically right now, processing is, as long as it's running, it is sending data over OSC, right? And actually, like, let's just make sure it's actually doing that. So it's send OSC. Yeah. Yeah. So basically, as long as it's running, it's just sending, it's continuously sending to Wekinator. Now, Wekinator is not receiving them yet because we haven't hit start recording. So as soon as we hit start recording, it'll begin to record. So let's do like a few classes, right? So how about this? The first one, I'll just do myself in front of the camera, and then I'm gonna associate that with class 1. I'm gonna hit start recording, and you see it's beginning to record. The values are going up. Maybe just move around a little bit. Okay, and like, you can let it go for a while, and hit stop recording. Okay, 360 examples recorded. Now I'm going to switch this to class 2. So you see that I've switched this to 2. And now I'm going to do something else. I'm going to move away from the camera. So like, let's do that. And then I'm going to start recording again. And we'll let some examples arrive. And now, let's also do one more class. And the camera pixels one is not terribly accurate, so, but this should be reasonably useful. So I'll put something in front of the camera, relatively close to the camera, and then I'll change this to class 3. And I'll hit start recording. And then I'll hit stop recording. And then we're going to hit train very quickly. And now we can run it. So what's going to happen is when I click run, it's going to begin to predict. Right, so there's class 1, class 2. You see it keeps on changing over here. And then Wekinator should be receiving this, and actually I forgot if it's, and then I think, one second. Yeah, okay, so first of all, also in processing, click the spacebar. So you should see this now. So now when it'll constantly tell you what's going on. It's not terribly accurate because it's these 100 pixels instead of a CovNet. It's really bad, yeah. With a 100 pixel one, it probably works best with just like when you're away from the camera.
Actually, are there 3 outputs or only 2 in processing?
There's only one output, but we train 3 classes.
That's what I meant. Are there 3 or 2? Classes?
However you trained it, yeah.
I'm saying 3 doesn't work in processing, so in the
Oh,
code.
no, it does. It does. You see that it just, it's whenever it just happens to be white. So white is 3, I think.
White on white?
Yeah, that should be, yeah. It's like, I don't know why it's, oh, wait a second. That's actually, I feel like that's a bug. Oh, you know what? Actually, I think showing input, current state.
There's the fill white right before the text.
You know what? This should be, this is wrong actually. I think this should be 1, 2, 3.
I don't think so. I think it's the fill at the bottom there that's 255.
Yeah, right. Yeah. But you know what? What's happening is that this should be actually 1, 2, 3, not 0, 1, 2. I think. Let me just see if that's correct. Oh yeah, there we go. Yeah. So there's a little bug in the code. You see where it says over here inside of draw, if is showing input equals false? Instead of 0, 1, 2, it should be 1, 2, 3. So that's a minor little bug. Huh, yeah. Anyway, yeah, so just fix that and then you have your three working. So this is the basic idea with processing. It's not terribly exciting, of course. Like, we'll start slowly and move our way up. But the idea here is that Wekinator does all the machine learning. It collects examples. It trains a learning algorithm, and then it sends output. Right? So, okay, so like what? So now we can begin to kind of like expand on this, right? So just as we did yesterday. So let's think about some things we can do. Right now we're just making graphics. Maybe we can improvise a little bit. Well, here, before we improvise, let me take you on a little tour of the examples here. Okay, so I'm just gonna, so you got the basic idea, and okay, here's what we'll do. So let me first take you through the code, just so you see the parts of the code, and then I'll show you a tour of the inputs and outputs that come with the Processing Wekinator folder, and then we'll try to code up something cool, right? And actually, just to raise your hands, how many people here are familiar with processing? Have you used processing before? So a good number of you. Like, it seems, raise your hand high. Like, okay, lots of people. Like, it seems like maybe almost half, something like that. So a lot of people are pretty familiar with processing. That's good. That means that everything that you know about processing, you can actually use here, right? So let's look at the code here. So if you look at the code, right, it imports the libraries, and then the main thing to be aware of is kind of inside of the. So there's a setup and the draw. The setup will basically set up the canvas and open the camera and set up the OSC. And then on the draw, whenever this is showing input, that's when you hit the spacebar. This becomes false. It starts as true, then it becomes false. So then it'll show the output. So it goes, okay, if your classification variable current state is basically equivalent to this. So our current state here is 1. If we do it then, it's 2, and so on. It's always, this is our current state. And all it's doing is that it's just drawing a rectangle and telling us the current state at that point. And otherwise, it's showing this, it's basically showing the pixelated camera. And this code you can kind of ignore. All it's doing is basically, this is the code that takes the camera input and turns it into something pixelated. And then at the end of the frame loop, it goes, so frame count is a counter that goes up by 1 every frame, and processing runs at, I forget whether it's 30 or 60 frames per second. I think 60, is it? Yeah, 60 frames per second, which means that it's sending 30 values per second, because it's only doing it on the 2s. And then the rest is just text. So basically, this is the method that sends OSC to Wekinator. It just creates a new OSC message called /wek/inputs and adds all of the pixel values to the message, and then sends it to using OSC. And then OSC, whatever is listening to OSC on that port, Wekinator will receive it and then will act upon it. And what Wekinator does is when it receives it, it figures out which class it is and sends the classification back to processing over OSC. And that will be received by processing here, void OSC event. And it goes, okay, I received the message called message. If the message's address pattern is /wek/outputs, which is what we set it to in the beginning, it will grab it and it will assign it to the variable current state. So 1, 2, or 3 will become current state. And then the key press basically just toggles that variable is showing input. So it toggles between looking at just the input versus seeing the classification at any given time. Does that make sense? Any questions about that? So like let's actually mess with this a little bit, and then I'll take you on a tour. Like let's do something with this that's more interesting. So sometimes I find the classification is actually like a bit harder to do interesting things with. Like maybe we can. So like okay, let me see what would be the easiest thing to do interesting. Regression is always much easier for me. Toggling between two different drawings. Well, actually, okay, so like one thing we can do is change this to using an images, right? So let's suppose I have some images that I want to toggle, and actually I think you can find them outputs, yeah. If you go to the folder outputs and go to, in Wekinator processing, outputs, classifier, and you see this images1 output, and inside of that folder called data, take these 5 images, 0 through 4, and copy them and put them into combined inputs output classifier data. So basically just put them inside. Sorry. So you should now also have them inside of classifier webcam. So now what I'm going to do is I'm going to make a quick image toggle. So we can go back to processing, and in the code, somewhere here at the top, anywhere, like after the OSC, I'm going to write p image IM1, IM2, IM3. So make sure you write that correctly. Capital P, capital I, image. And then in setup, anywhere in setup, like maybe after the font, you'll do the following. IM1 equals load the image. Make sure you capitalize the I. And then in quotation marks, 0.jpg. And then do the same thing for IM2 and IM3. For like the next 2 images. So IM1, IM2, and IM3. Just like this. Okay, people got that? Still typing? And then what you'll do is you'll go down to draw, and you see where it goes here, fill 0, fill 255, fill that, right? Now do the following thing. So after, let's do this. Let's say after the text here, you'll do if current state equals 1, open brace, image IM1, and 0, 0. If current state 2, image IM2, 0, 0. And if current state equals 3, image IM3, 0, 0. So as long as you still have processing running, Wekinator running, you can run this, and then as soon as it comes up, hit the spacebar again. And now it's going to begin to give us some dogs. Turtle. It's not terribly accurate, but it does the job. Okay, people still writing that out? Yep. Yep.
With the vendor, I said, But now the data just copy it, copy it from here, paste it into the now it's complaining about now some font.
Oh, because you have to copy the data folder from the other one, save that, save that new sketch, and then make a data folder with that font inside. Okay, shall we proceed? How's that working, people? Okay, so let's oh, yeah? It depends on the complexity of the question was like how many samples do you need? And you know, typically for like this small image classification task, you can get away with a few dozen even. But generally more is better, but at some point it kind of stops learning, so you don't need to do it for that long. Okay. Okay, so let's scale this up a little bit. Now over here if you look at the folder, okay, if you look at the folder here, you see that there's a few, there's a folder called inputs and a folder called outputs. And this actually, so this one sketch that we ran shows how to do both. It shows how to have one processing sketch communicate both up and down with Wekinator. Now, in general, you don't have to do this. You can do it like a little bit. You can have two processing sketches if you want, communicating separately with Wekinator, or you can combine them. Let's actually look at some of the inputs. So here, let's go ahead. You can get out of the classifier webcam example, and you feel free to save it if you want to. I'm going to let it be how it was before. And let's look at the face detection 3 inputs. Now for this, I think we'll have to install one more library. So open this because I think you'll have to install OpenCV. Some of you may have it, but if you don't, if this doesn't open for you, go to import library, add library, and search for OpenCV. And you'll see OpenCV for processing by Greg Bornstein. So please install that. I'm gonna update mine. This may also take a few minutes, so while it's downloading, let's just see if that starts. Okay, this might take a little while. Yeah. People are having something similar to me. It's like really slow. Okay, that's fine. In the meantime, I'm going to tell you what this does. So let's see. So this is going to send face tracker data to Wekinator. It's going to look for your face or anybody's face that happens to be in your webcam. And it will, if you read through the code, you'll see what it does here. It looks for the biggest face inside of the image, if there are multiple faces. And then it will, let's see, it will take of the biggest face, it'll grab the X value, like the rectangle of the face, it'll grab where it's located, the X and the Y, and the width of the face. Now, and I don't mean like in inches or something, but in pixels. So if you get closer, it'll be bigger. So it'll take those three values, x, y, w, and it will send them to Wekinator. So it's just an input of 3. Okay, so what I'm actually going to do is, once this is done downloading, we'll actually, while it's downloading, let's set up Wekinator to accept that. Okay. Now, first of all, this sketch is just an input sketch. It's just sending input data to Wekinator. It's not actually set up to do anything except for sending to Wekinator. So we can do with it whatever we want. So maybe what we can do is we can actually, we have a lot of things we can do. Like we can make a processing sketch on the other side which will receive the data. So that'll be actually a good exercise. So here's what we'll do in the next, I think, 30 minutes. We'll train this on the face classifier data. We'll make a sketch to receive the data from Wekinator and do something interesting with it, right? And then I'm going to show you the robot key press output because that one was really fun. Okay, so first of all, how many people are still downloading it? Looks like I'm still downloading. How many people have it ready? Okay, like half and half. Okay, so let's let that download. In the meantime, let's go ahead and stop Wekinator. And let's go to Wekinator new project. I'll have a new project here, and you can get out of the old one. And let's do this. Let's make some fun generative art. So what I want to do is we'll start listening. Sure, nothing else. If you get this could not bind to port, that means you have some zombie process still running. Yeah, because this is still here, so just remove that. So get rid of the old project, and then you can start listening. Now it says listening on port 6448. And then set up in the inputs 3 inputs. Okay? And we'll do 1 output. And let's make it continuous. We'll say all continuous, so leave it at all continuous. Now make note of this. It's the OSC message it's expecting is /wek/outputs, and the port is 12,000. So we'll use that again. So go ahead and click next. So you have that there. How many people did the library download for? Okay, who's still waiting? Okay, lots of people. Okay, so let's leave that aside and let that kind of load. In the meantime, while that's doing, we're going to create a new processing application to receive data from Wekinator. And we can actually run that right away. You'll see the Wekinator is kind of nice. We can run things separately. So go to processing, file, new. Okay. So you have a new sketch. So let's do the simplest thing. Let's just start with a void setup and void draw. And we'll make a canvas of size 500, 500. So if you run this, you should get something like this. So let's do the following. Let's go to Sketch, Import Library, and then go down and find OSCP5. And it should just put these import statements at the top of your code. So now, at the top of your code, after the import statements, we're going to declare an OSCP5 object, which is going to be the object which receives data from Wekinator. So we'll say capital O, SC, capital P5, and we'll call it OSC. And then in setup, you say OSC equals new OSCP5, and in parentheses this, and then the value, the next argument is the port number that it's listening on. So remember that we set up Wekinator to send on port 12,000. So we're going to have this processing sketch receive on 12,000. So make sure you can run this and you don't get any typos, no compiling errors. If you get an error, read the message and it's probably a typo. Something like missing a semicolon or something's not recognized because it's not typed exactly. So just be careful with typos. So now we're going to create a method to receive OSC messages. Let's see if I remember exactly how to do this. It's going to be void OSC event, and then it's OSCP5 message, and then we can call it MSG. Let's see if that actually works. No. So hang on a second, it's not OSCP5 message, it's OSC message. Not OSCP5 message, OSC message. There you go. So basically what will happen is, whenever, so this is an automatic event. This is OSCP5 recognizes whenever, with only this exact method title, this gets called whenever you have a message. So we can say, okay, string with a capital S, address equals MSG, and then I've always found the OSCP5 library to have very strange semantics for this, but it's get addr pattern. It's really, I think that's what it is. Is that right? No, it's not. What is it? It's, hang on a second. Combine inputs. We'll just look at, so whenever you forget something, you can always find it somewhere else that you've used it. So, oh, check addr pattern. Oh, I see. So basically, we'll do this instead. So you go if msg dot check addr pattern. Oh, wait a second. Is that what it was? Sorry. Yeah, exactly. Check addr pattern, and then slash wek slash input slash outputs. So basically, this creates an if statement that says if the message has the address slash wek slash outputs, then run the following block of code. We'll say that float value equals message dot get 0 dot float value. And then maybe we'll just print it to the screen. So we'll say value, print line value. Basically, if you've done this right, you should be able to run this sketch, and then as you move the slider around, you'll see it'll begin to print it to your console down here. So now we've shown forward communication from Wekinator to processing. Okay. Anyone have any difficulties? So you might get some typos. Just make sure that you have got that right. Okay, you guys ready to continue? So let's do something cool with this value. So let's first make some sort of an interesting drawing. And I'm going to pull out another one of my favorite generative art strategies, which is deforming a circle. That sounds really odd, but it's going to be kind of cool. So let's deform a circle. So in processing, the way to draw a circle, of course, okay, so let's first of all, let's make a black background. So now if you run this, you'll have a black background. Now we can say, okay, how about this? You can make a circle in processing and put it in the middle of the screen like this, right? Like, let's say a 200 radius circle. Oh, there is no circle? It's just ellipse? I thought there was a circle too, but okay. So ellipse 200, 200. Okay, great, right? Beautiful. But what's much cooler is to draw a circle manually. How many people here know trigonometry? Yay. Who knows what a cosine is? Okay, most people here know cosine, okay. So we can actually derive the equation for a circle and make it manually point by point. Now that may seem tedious, but it'll be kind of cool because then later we can do something else with those points, right? So how about this? Instead of doing this ellipse thing, we'll say okay, how many points do we want, right? Say int n equals, let's say for now, 10 points. So int n equals 10. And we'll say for int I equals 0, we're creating a loop. I is less than n, I plus plus. Sound when I, wow, that's so strange when I tap on the keyboard. Is that visible to everyone? Does everyone hear that, or am I just going crazy? Yeah. So I guess that's the, oh, I guess it's just the microphone. Yeah. All right. Well, that makes sense. But it's just a tap. Anyway, I'm going crazy. So okay. So inside this loop, we're going to make a bunch of points. So first of all, what are those points? We need x and y values that go around the circle. So first we need the center of that circle. So let's go up here and we'll say that float cx equals width over 2, and float cy equals height over 2. So cx and cy are going to be the center of our circle. So then what we can do is we can figure out 10 points evenly distributed around the circle. We can get the actual point value using trigonometry. So let's say, first of all, we need to figure out what angle we are. So we go from 0 to 2 pi in 10 steps. So you can say float ang, let's call it ang for angle, equals, and then basically we can use the map command in processing to map the value. So map takes a value and it remaps it from one range to another. So you'll see what I mean when I've completed it. You say map I from its original range of 0 to n to now 0 to 2 underscore pi. Make sure that's all capitalized. And then you can say float rad equals 100. So that'll be our radius. So then the point, the x value is going to be x equals cx plus rad times cosine angle. And y is equal to cy plus rad times sine angle. So that's the equation for a circle. So everyone's kind of seen this before. So let's do a really simple thing first. Let's just draw a small ellipse at xy. So if you do this, you'll get 10 points evenly spaced around the circle of radius 100. We can make this a little bit interactive. How about this? We'll take rad and we'll make it equal to mouse x, mouse capital X. So now you see that the radius changes according to the mouse. We can give it more points as well. How about we say int y equals mouse y, int n equals mouse y. So that'll give us more points. Okay, cool. But anyway, let's just go back to 10 and 100. And let's actually make a circle by using the begin shape, end shape functionality in processing. So you, before the loop, you'll say begin shape with a capital S. And then at the end of the loop, you'll say end shape. And also close. End the shape, close. So this will close the shape. And then instead of an ellipse here, we're going to erase that. And we'll leave it at, we'll write vertex x, y. So if you run that, it's going to create a shape with the following vertices. Right. Now what we can do is, before the begin shape, let's get rid of the fill. We're going to write no fill so that it doesn't paint it inside. Oh, and then blank because we have to make it, let's make it now white. So we'll say stroke 255. Okay, fantastic, huh? So, so now let's do the following. Let's say that we can, instead of having just 100 here, we can create random deformations, right? We can say 100 plus random, 50. So now if you run this, it's going to just have a, like the points of the circle are going to be given a random addition of somewhere between 0 and 50. And it's being done on every frame, right? Now, that's not so cool, right? Maybe it'll be a little bit cooler if we, well, let's see what happens first of all. How about this? Instead of 10 of these, let's have 100. Now it's a little crazier, right? What if this whole thing were random? So instead of 100 plus random, we'll say random 150. Okay? So now that's not so cool, right? But remember, this is my generic way of making anything in processing that uses random go from being not cool to cool. Replace random with noise. So instead of random, we're going to use noise, and noise works in the following way. So we'll say 150 times, and noise is always a value between 0 and 1. So like if I just do noise of 1, all of the points will have the same value because noise of 1 at any given time is one value. No matter what. No, every time you call it, it's not like random anymore. It actually has a single value. So in this case, we can give it different values by doing noise of I instead. Because now they'll all have different values. So some value between 0 and 1. Now the idea is that noise, like the smaller the differences you make in the argument, so to two noise values, right, like noise of 0 and noise of 0.001 are going to be very similar to each other. There's kind of an organic noise pattern, like it's very smooth. So if we bring these closer together, let's say by multiplying it by 0.01 times I, it will suddenly look much less erratic. Looks like a potato almost. Maybe 0.1 times I, you'll see, 0.1 times I, you'll see kind of something like this, right? So here's what we're going to do. We'll do 0.1 times I, and then we'll add another argument to noise, a second dimension to the noise, which will vary according to the frame count. So we'll take frame count, which is the number of frames, and we'll multiply that also by 0.01. And now this thing will start to move. Okay, let's make it a little bigger. 300 times noise. Okay, so now let's finally make this interactive. So we'll say, instead of being noise 0.01 times I, we'll take this value that we're receiving in the OSC and we're going to connect it to this right here. We'll declare a new variable up top here called float noise AMT, or let's use something more simple like R. Float R. And instead of value equals this, we'll get rid of the print statement here, and we'll say that R equals message get 0. And then we'll make this R. And now if we take the slider, we can now control the value of the smoothness. Okay, so now we have something basic. So now let's connect it to our original sketch. And by now I'm sure everyone's downloaded video, right? So now let's go back to the video input, or the face detection, right? And you still have this open, right? So remember to, yeah? I'm sorry? Declare it, yeah. So if you put it up top, float R. I'll try to make this so that you can see everything. So you should have basically this here. So now I'm going to go back to this face detection sketch, and I'm going to run this. So this should open for you now. Once you've installed OpenCV, you should have a thing that checks your face. Okay, so let's connect these. Let's train this. This is sending to Wekinator. So how about this? I'm going to put the slider at 0. I'm going to put my face kind of in the top corner here and far back. Or like maybe somewhere in the middle, let's say. And then I'm going to hit start recording. And I'll maybe like wiggle my face around just a little bit. But kind of somewhere in the top left corner. Stop recording. I'm going to switch the slider to 1 and now record some examples over here. So I'll start recording and I'll record some examples here. So now, once I've done that, I can hit train. That will train it. And then I can hit run. And now I can control the slider with my face. And remember, the slider is controlling our processing sketch. Sorry? What was that? I Can't hear you. Can you speak up? Why not? Is it not connecting? You're not receiving OSC? I'm people have got something like this going. Yeah. Okay. So let's do this. So we're at about 7:30. So like I'm going to come around and help some people if you're having some troubles, and then we can also just like take a break also. So once you've got this running, we can take a quick break. So get something like this running. Yeah. Yeah. So this is the code here. Okay. Who's having some Who's having some trouble? Okay. Let me come around to individuals.